Hello class, how are you doing? I'm going to take a few minutes of your time and discuss about proper and improper. You have heard these two terminology in mathematics a lot. I think you're still talking about this in a third grade because your teacher talked about proper fraction and improper fraction. Proper fraction was the top, it was smaller than the bottom, but if the top and bottom, numerator, denominator are the same, or the numerator is larger, these are called improper. Then you came to algebra, and you talk about polynomials, and you said if you have a polynomials on the top, and you have a polynomials on the bottom, and when I compare these two polynomials, if the polynomials of a top, the power, the leading variable, have a power less than the leading variable of the bottom, that's proper, just like those numbers. Means I can have x cubed plus 5x squared minus a 7 over 2x plus 2x to the power of 4 minus 7x. See, the leading variable is here. And what is the power right here? 4. The leading variable is here. What is the power? Is 3. Therefore, see, 3 is less than a 4. That's proper. But when you said the power of the top is the same as the power of the bottom, or the power of the top is bigger than the power of the power of the top is bigger than the power of the bottom, these two called improper. And we have discussed this in calculus many times, because if you have an improper rational function and you try to integrate it, you have to change it to proper. And how do you change it to proper? The same as you did here. How do you change this one to a proper? That become a mixed number, and that become 2 1/2. You get a number and a proper fraction. In here, you're going to get a polynomial and proper rational function. In here, you're going to get a polynomial and proper rational function. You have to do long division to make it to proper. That's today we're going to talk about proper and improper integral. Okay, this is a proper integral from A to B. What does make this one a proper? Number one, that function, whatever that function is, if it's x, if it's natural log of x, if it's sine of x, whatever if it's a sine of x, which is like that, or if it's a natural log of x, or if it's the line of y equal to x, you only can take the definite integral of a piece which is above the x-axis and is positive value. Somebody say, well, what happens if I go from 0 to pi? Well, this area and this area are the same, but this one is going to be positive, this area is going to be negative, and it's going to offset each other. And if I ask you what is this area plus this area, you cannot say it's 0. That's the reason for this area, you said top minus a bottom, but your bottom is 0. For this one, you put top minus a bottom, 0 minus a bottom, the answer would be negative, negative times negative, make it a positive. Therefore, really a proper definite integral, this function has to be positive. What I mean by positive, for every number you give to the x, between lower limit and upper limit, the graph must be above, and the function must be continuous. You cannot have a discontinuity right here and say, okay, I need the area between the curve of this side and that side. No, you can only talk about that side. You cannot have any discontinuity. Therefore, that is a proper definite integral. But what happens if I go back right here and say this one is nothing except 1 over x plus 3, and I'm going to go right here from 2 to 6. I said, you know what? Even though x cannot be negative 3 is not between 2 to 6. Is not. That is still a proper definite integral. It will become improper if the number make the bottom 0 is landed between the 2 and a 6. For example, if I have a -1 and a 5, and I come up with 1 over x dx. See, x cannot be 0, and here is 0 is between this and this. That's make it improper. But also, I have negative 5 to 5 of 1 over x squared minus a 9 dx. Two numbers cannot make the bottom 0. Is negative 3 and 3. And both numbers are between negative 5 and 5. Therefore, that is also improper. And somebody said, how do you solve these? You have to write the definite integral for that piece. You have to write the definite integral for that piece. And you have to write the definite integral for that piece. Then you ask me a question. What happened if the endpoint is not included? I said, I'm sorry, that is still improper, because for definite, your lower limit and upper limit must be included, and every point between a lower and upper must have a y value. Therefore, it must be defined for every one of them. Therefore, this one, your a is 1, and your 1 is excluded because 1 cannot be in the denominator. That is still is improper. Somebody said, how do you do this? The number make your bottom 0, you're going to assign it to a real number like something like a. And said, don't put negative 3, but you can have negative 3.000000001 and go from a negative 5 to negative 0.3000001, which is really to the right of it, but it's not much different from a 3. But that's too many zeros here. How many zeros I'm going to put to have the smallest number larger than negative 3? I said, you don't have to put all that 0. Just call it an a. Then take a limit and say a must be approaches 3 from the left. Then when it approaches from a 3, you can have as many zeros as you want. And here you're going to put 1 over x squared minus a 9 dx. That's for that one. Then you have to put plus. What did I call negative 3? I call negative 3 an a. But for this piece, you're approaching 3 from a negative. For that piece, you're approaching 3 from a positive side. Right side, and you go from a. But what am I going to put right here? That number is not defined. Somebody said put b right here. Well, if I call this one a b, then do I have to attach another limit? Have you heard of limit of the limit? You cannot do that. You have to go between these two and pick a number which is defined, and the easiest number between these two is x equal to 0, and put 0 right here and put 1 over x squared minus a 9 dx. Okay, I got that piece pretty correct. Good. Then I have to write 1 for that one. Then you have to say plus limit of 0, that is defined, but it is not defined at 3. Instead of 3, I put b, and I'm going to take the limit as b approaches in 3 from where? From a negative, from the left side. And this has to be a negative 3, not 3, because that's a negative 3. But this is 3. And then you're going to put 1 over x squared minus a 9 dx. Okay, I took care of that one. I'm sorry. What am I going to do with that piece? Oh, I can have 5 inside my domain, but I cannot have a 3. Therefore, give me the smallest number larger than 3. That number, I'm going to call it a b, and I'm going to take a limit. Therefore, tell me what I write right here for that piece. For the last piece, I take the limit as b approaches 3 from a right. Remember this one from a left, from a right, of b to 5 for 1 over x squared minus a 9 dx. Do you see this stuff? It is doable. It's not hard, but it's time consuming. Therefore, if you do have improper integral, you have to change it to a proper by attaching a limit to it. Then somebody said, oh, well, what happened if I have 1 to infinity of 1 over x squared dx? Well, infinity is a huge number. What is the graph of 1 over x squared? That's the reciprocal of a parabola. The graph is right here. And I go from 1 to infinity. Oh, that's the area under the curve. Okay? But I cannot have infinity. I don't know where is the infinity. I'm going to call my infinity a, and I'm going to take the limit as a approaches a large number, which I don't know what that large number is. Therefore, this is a definite integral. I'm going to take my definite integral, and the integral of that one is x to the power of a negative 2, which is negative 2 plus 1 over a negative 1, and I put it from 1 to a. This is negative. I can write the negative here, and negative 2 plus 1 is negative 1. Negative 1 comes on the bottom. That becomes negative 1 over x from 1 to a. Then the answer is negative 1 over a minus negative 1 over a 1. And the answer is negative 1 over a plus a 1. This is the area under the curve, but I don't know what that a is. I'm going to make that a number very, very, very close to infinity. Maybe put 1, 0, 0, 0, 0. Maybe I put 1 trillion 0. I can't do that. Therefore, I'm going to take the limit of that answer, and I'm going to say a approaches a huge number. And what is 1 over infinity? 1 over infinity is a very small number. Because if you have $1 and you want to split it between 1 million people, everybody going to get something, but it's very tiny. Therefore, this is approaches 0. I didn't say 0. Approaches 0 plus 1. Therefore, that area under the curve right here, I got 1. Is it really 1? No, because that approaches 0. Maybe this 0 is 0.00000000001 plus 1. Therefore, that is not 1. That's close to 1. Then you better say that improper integrals approaches 1. Because it approaches 1, it converge. I don't know what number does it converge to. I'm sorry, I said it wrong. I know it is converging to 1, but it is not 1. It said it converges to 1. It approaches 1. But only, therefore, we have 2 types of improper integrals. The one converge and the one diverge. Therefore, you have to tell me, if your answer is a finite number, you said converges. Somebody said, okay, can you give me an example of diverges? I put 1 over x from 1 to infinity. And what function is derivative is 1 over x dx is a natural log of x. But you cannot have infinity. I'm going to call this one a, take the limit as a approaches infinity. And I'm going to write this one as 1 through a. Therefore, I'm going to say natural log of a minus natural log of 1. Natural log of 1 is 0. Right now, this is the area under the curve. But tell me what is a. I'll give you the natural log of that number. In here, a, this is a graph of a natural log of a, natural log of x. And a is your x value. When x gets bigger and bigger and bigger, what happened to the area under the curve? Let me take the limit as a approaches infinity. And natural log of infinity is undefined. Undefined means approaches a huge number, approaches a large number, and this one said diverges. Therefore, we have 2 types of improper integrals. Improper integrals that you do have a lower limit and upper limit, which one of them, or maybe both of them, is not part of the domain. Or maybe the lower limit and upper limit is part of the domain, but there are some numbers between lower and upper that is not part of the domain. Therefore, those are called improper integrals, and the only way you can do it, you assign the number, which is, you cannot assign it to the domain, to the x, a or a b or a c or a d, and take the limit as you are approaching that number and solve it. And your answer is going to be either converges or diverges. Thank you.